Welcome to ICUDemy, the educational channel of the Critical Care Society of Kenya. In this lesson, we'll explore airway resistance. Airway resistance reflects the impediment to ventilation imposed by the airways, and also by the endotracheal tube. It's generally estimated by dividing pressure by flow. In order to understand flow mechanics, we introduce the Hagen-Poiseuille equation. It states that flow is directly proportional to the pressure difference between 2 points and to the fourth power of the radius. It is also inversely proportional to the viscosity of the fluid and the length of the tube. Borrowing from Ohm's law, we define resistance as the ratio of pressure difference to flow. When we rearrange the equation, it becomes clear that resistance is inversely proportional to the fourth power of the radius. This means that even small increases in airway radius leads to an exponential drop in airway resistance as children grow. With this background, we can explore the factors affecting resistance both in normal and altered respiratory mechanics. We shall start with age and see how it influences resistance. As age increases, the airway diameter also increases. Premature newborns have the highest resistance. It drops significantly in term newborns and continues to fall in infants, teenagers, and finally adults. This curve captures the exponential decline in airway resistance with increasing age. Next, we explore the relationship between airway resistance and tracheobronchial divisions. The tracheobronchial tree has 23 generations, with the diameter gradually decreasing at each step. The highest resistance occurs in the medium-sized bronchi. This is due to the fact that they have the smallest total cross-sectional area despite being numerous. As we move further down the airway tree, resistance rises to a peak and then falls steeply as the airways branch and multiply. Generation 16 marks the transition point from conducting airways to the respiratory zone. The conducting zone starts from the trachea and ends at the terminal bronchioles. Beyond this point lies the respiratory zone, where gas exchange takes place and resistance forces disappear. Lastly, we examine how resistance varies between the inspiratory and expiratory phases. In volume control ventilation, inspiratory resistance can be estimated using the difference between peak inspiratory pressure and plateau pressure, divided by the inspiratory flow. Expiratory resistance, on the other hand, is estimated using the mean expiratory flow and the pressure difference between plateau and PEEP. Inspiratory resistance is typically lower than expiratory resistance, owing to the increased diameter during inspiration, particularly in chronic obstructive pulmonary disease and dynamic hyperinflation. Thanks for watching.